This is the tutorial on circles. We're going to cover three main topics in this tutorial. First, the definition of a circle. Next, writing the standard form of the equation of a circle. And finally, working with the general form of the equation of a circle. First, the definition of a circle. A definition of a circle states that a circle is a set of points in the xy plane that are fixed distance r from a fixed point hk. The fixed distance r is called the radius, and the fixed point hk is called the center of the circle. Graphically, let's see how that is defined. So this graph represents a circle with radius r and center point hk. To find the equation, we let xy, the point at the top here, represent the coordinates of any point on a circle with radius r and center hk. Then the distance between the points xy and hk must always equal the radius. That is, when we plug in these two numbers into the distance formula, which we saw in the preceding tutorial, we come up with this equation. We get the square root of x minus h squared plus y minus k squared equals r, the radius. So then we square both sides and we get this result. We arrive at x minus h, the quantity squared, plus y minus k, quantity squared, equals r squared. The equation you see is indicated right here. X minus h squared plus y minus k, quantity squared, equals r squared. Standard form of an equation of a circle. Another important definition relates to that of the unit circle. The standard form of an equation of a circle with radius r with a center at the origin 0, 0 is x squared plus y squared equals 1. And that is called the unit circle. This is a graphic representation of that unit circle. We have the center at point 0, 0, and the radius goes to point 1, 1, 0, 1, negative 1, negative 1, and 0, negative 1. So you can see right there we have the unit circle. Let's look at an example. This problem says, find the intercepts, if any, of the following circle. So this is the equation that we're given. X plus 3 quantity squared plus y minus 2 quantity squared equals 16. Well, by looking at the equation, we can see that it is already in the form x minus h squared plus y minus k quantity squared equals r squared. So that tells us that the equation is a circle, and we know other bits of information. We would know h would equal negative 3, k equals 2, because looking at these values, we know that negative opposite of h would make it negative 3 because we have a plus in the equation. K equals 2, and we know that r squared equals 16, so r equals the square root of 16, which is 4. So we know the center of our circle is at point negative 3, 2, and our radius is 4 units. Let's go ahead and look at how that looks on a graph. Okay, so I've plotted the center of our circle at point negative 3, 2, and then we can plot other points by the information we know because the radius is 4 units. So if we go to negative 3, the center of the circle, and go up 4 units, 1, 2, 3, 4, we would put a point at negative 3, 6. We can do the same thing counting down from negative 3, down 1, 2, 3, 4, which puts us at negative 3, negative 2. And then if we go ahead and go over, we would go over from the center 4 to the right, 1, 2, 3, 4, which puts us at point 1, 2, and 4 to the left, 1, 2, 3, 4, which puts us at point negative 7, 2. These 4 points that we just plotted can then be used as a guide to graph the circle. And when we graph this equation, this is what the circle looks like. Now that we have the graph, you can see the graphic representation of this equation, but the problem says to find the intercepts of any of the following circle. So for this circle, we want to go ahead and find the x-intercepts, if any, and the way we would do that is, first of all, we would let y equal 0 and solve for x. So we have our equation x plus 3 squared plus y minus 2 quantity squared equals 16. we're going to go ahead and say x plus 3 squared plus 0 minus 2 squared equals 16. Then we're going to simplify, so we get x plus 3 squared plus 4 equals 16. We have x plus 3 when we take the square root plus or minus the square root of 12 because we've subtracted the 4 from the 16. And we're going to go ahead and solve for x. We get x equals negative 3. We subtracted the 3 plus or minus, factoring out 2 times the square root of 3. And if we solve that on a calculator, we find the x-intercepts equal negative 3 minus 2 times the square root of 3, which is approximately equal to negative 6.46. And the other x-intercept is negative 3 plus 2 times the square root of 3, which equals roughly 0.46. Now to find the y-intercepts, if any, we're going to let x equal 0 and solve for y. So we do the same thing with the equation x plus 3 quantity squared plus y minus 2 quantity squared equals 16. And then, of course, we put 0 plus 3 squared plus y minus 2 quantity squared equals 16. 9 plus y minus 2 quantity squared equals 16. Y minus 2 squared, subtracting the 9 equals 7. Y minus 2 taking the square root equals square root of 7. We get y equals 2 plus or minus the square root of 7. So when we go ahead and solve, we find that the y-intercepts are 2 minus the square root of 7, which is approximately equal to negative 0.65. So when we go ahead and use our calculator to solve y equals 2 plus or minus the square root of 7, we find out that the y-intercepts are negative 0.65 and 2 plus the square root of 7, which is approximately equal to 4.65. And it's always a good idea when you do have a graph to go ahead and verify your work. We see that the y-intercepts we got algebraically are negative 0.65 and 4.65. Let's just look on the graph to make sure that makes sense. When we look on this graph, we see, yes, going up here on the y-axis, we have an intercept right about there at 0, negative 0.65 and 0, 4.65, just under 5. So yes, our work makes sense. Our equation was solved correctly. Next, we want to talk about the general form of the equation of a circle. If we take the same equation that we've been working with, we take x plus 3 quantity squared plus y minus 2 quantity squared equals 16. If we go ahead and multiply that out and remove the parenthesis, what we get is x squared plus 6x plus 9 plus y squared minus 4y plus 4 equals 16. So if we go ahead and simplify that, we get down to x squared plus y squared plus 6x minus 4y minus 3 equals 0. It can be shown that any equation of the form x squared plus y squared plus ax plus by plus c equals 0 has a graph that is a circle or a point or has no graph at all. For example, the graph of the equation x squared plus y squared equals 0 is the single point 0, 0. The equation x squared plus y squared plus 5 equals 0 or x squared plus y squared equals negative 5 has no graph because sums of squares of real numbers are never negative. So we get to this definition, the general form of the equation of a circle, when we see that x squared plus y squared plus ax plus by plus c equals 0, we know that that is the equation of a circle. And we use the method of completing the square to put the equation in standard form so that we can easily identify its center and radius as we have seen in this tutorial.